All right, you're listening to the Drop-Tine podcast. I've got no informal intro today. By the way, I just want to jump into this because I have a feeling this is going to be a not a lengthy conversation, but I want to save enough time to address this. So, in some of the episodes, you may have caught some comments about a tool, a soul health tool that I've been working on with Dr. Rick Haney. So we wanted to just start with a podcast sort of talking about the why, the history of this tool, the development of this tool. And to do that, I've already had a colorful conversation started here. Hopefully I hit record at the right time with the now retired Dr. Rick Haney. And we also have another. Dang, David, you know what? I just realized you keep doing this and you're going to be a co-host soon. David Kleinschmidt is here. You guys there?
Yeah, we are here.
I thought you were going to play a joke on me and not be there when I'm ready. Well, guys, so I'll just throw this out there. So again, the soul health tool that we're going to talk about more in depth has been something that Rick and I have been working on for 2 years, maybe a little bit more than that. When you consider the talking and mental approach to how the heck we're going to do this. And as we developed this tool, this technology, like any other, tool, technique, whatever, you have to have people who are qualified and people who understand its application. And thus, that's where we brought David in. David's been along with us for most of the ride, except for the part where I had GNTs on an island in Florida, and Rick had them all over the state of Texas and Kansas and Oklahoma, etc. So, with the three of us, I think what I really want to kind of talk about real quick, Rick, with you and I, is years ago, I don't know, 3, 4, whatever it's been, I decided although the Southeast Deer Study Group meeting and some other meetings, conferences were fun, I enjoyed the people, I needed to get outside of the deer world and the wildlife world and really engross myself in soil. Up until then, everything I had done from a soils standpoint was conventional, focusing on soil organic matter. And you can go back and listen to one of the first podcasts Rick and I had together and really hear, some of the history on that. But so I went to Kansas to the Soul Health, I think Soul Health U or some kind of soul event with really 1 or 2 people in mind who I wanted to meet. Unfortunately, David was actually working, making money, so he didn't go. But this guy named Haney was there, and I approached him, and we ended up sitting down for a glass of water. Right, Rick?
Yeah, it was a really strong glass of water.
Right, brown water. And we started to have this conversation, and I remember saying to you, Rick, correct me if I'm wrong, I said, I don't get it. It seems to me that the farming, agricultural, soil world is antiquated. I have to go out in a field, regardless of where I am in the country, let's just say New York, Pennsylvania, whatever, Indiana, dig a hole, put it in a bag, and send it to you in Texas, right? This is crazy. This is what they call in the literature a destructive soil sample. Am I right? So once I send it to you, I can't ever retest that sample. So in other words, I cannot adapt my management to trend in a better direction and improve things. So that was my issue with the soil world. And I said, don't we have technology? Can't we develop some in-field soil health tool where we as consultants and a grower who's interested in the regenerative soil health world can take it out there and instantly gain a better understanding for how the life is working beneath the soil? And you looked at me and smiled and you said, I've got a project. Do you want to work with me on it? Do I recall that correctly?
Yeah, that's close.
I might have missed some details, but you kind of.
You told me you thought the first thing you told me is you thought I was really handsome when you sat next to the bar. So that appealed to me right away.
Yeah, that was a different bar. You're confused.
Oh, never mind.
No, this didn't happen. See, now you can't do this.
David backed me up on that.
David wasn't there. He was in a different state.
Not me when he met you.
He wanted to make me for breakfast once, and I thought that was kind of weird.
See? There's a trend here.
Yeah, and I remember that breakfast too. That was legit.
It was all fun, and we're thinking about, all right. So I've been wanting to do this infield, some sort of infield test, in the field, not because I understand the issues with pulling samples and sending them to a lab, and it's always amazed me that the soils are so resilient and so consistent that we can pull a sample from this field versus that field and see the differences, even though we pulled it up, put it in a bag, shipped it across the country, dried it, ground it, re-wet it, and done all these things to it, right? It's amazing to me that those differences show up. But you also know that in doing that, we tend to miss something. And so the fun part about that whole thing is, the Soil Talker -1 system. So in the write-up you sent me, I'm working on that. So what I'm saying, so the lab respiration is potential. The Soil Talker -1 system is real time.
All right, let me jump in because the listeners are going, what the hell is he talking about? So we've struggled over the last 2.5 years to name this thing, right? And there's kind of this joke between Rick and I. We struggle. Well, it's going to come to us. It's like naming a buck, right? Everybody loves to name their bucks, and sometimes you can't name them too soon. You got to wait a while and see what his behavior is. What he throws on his head, something unique. So we were like, hey, we're really stressing about what to call this thing, right? Because you want to have some sexy name. And Rick started calling it the Soil Talker system. Am I right? Isn't that kind of the first? You're like, hey, this thing, if we listen, we can hear the soil talking to us through this thing, which is kind of abstract and Rick Haney-ish. But yeah, that was, and then we started calling it the Bio Machine and several other names. So the tool is now called ST1. There's a hyphen in there, as Rick accented the hyphen. So that's kind of the backstory. So again, it's the ST1. If you hear us say Soil Talker System Bio Machine, the GNT is the tube that is inserted into the soil that does some things. We can't tell you everything, or we'd have to,
Kill ourselves.
That's right. Kill ourselves. But anyway, so go ahead. I wanted them to sort of understand what the heck you're talking about.
Well, but you touched on something there that I really deeply believe in that for centuries we have decided that we need to grow this or that here or there, and we're going to go out there and do it this way because we know what we're doing. Nobody ever stopped and paused and asked, what if we had the tools to listen to what this soil is trying to tell us, what would it say? Maybe there's a better way to do this than what we're doing, just, based on our collective knowledge.
What do you mean by listen? When you say listen, what are you listening to? The soils are just, is it not just a dead dirt soil, that sand, silt, clay? You're talking about particles and...
Yeah, that's what we broke it down to. Well, look, it's just sand, silt, and clay. It's like there's nothing living in it. Well, okay, that couldn't be more wrong. The fact is that the sand, silt, and clay are the backbone of soil. And, it's like the skeleton of a human body. It's, it's just there, holds the thing together and all that. But, it's the biology that drives the system.
Right.
If you were just a skeleton standing there with no energy, it'd be a fairly boring world.
So that's what we want people to understand. And I told you, Rick, here about a month ago, I said, hey, we need to do more podcasts on soils because people, they still don't get it. And I can relate to that because it took me, as I'm sure you'll have fun revealing, years of prying and asking you questions and saying, I don't get it, I don't understand. And then you finally had to dumb it down. And actually the thing that I think you've watched me kind of maybe grow a little bit on this is actually having the ST1 in the field and using it. That's where I learned. One of the first things you said, before I get too far ahead of myself, when I was worried about, hey, we need to be able to correlate this back to, the amount of organic nitrogen that they can credit in the system and blah, 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 blah. And you said, whoa, slow down. The most important aspect of this whole, the tool and the idea of getting out in the field with it, or as they say, in situ, in the field, is we're going to learn a lot from this tool. Even things, that's what I said, what do you mean we're going to learn a lot? You're Dr. Rick Haney, right? You know it all. You're a soil scientist. You're now retired from the USDA, 19 years of doing that. You have a PhD. And you said, no, we're already learning things that we didn't comprehend or had no clue was going on, when it was going on, by having this tool. And that sort of blew my mind and sold me on the idea. So I guess before I get too far, I remember saying to you, well, what's available out there regarding this? And I want to talk about the Solvita paddles, and remind me about that if I forget. But me being me, I went and did a literature search and started reading the papers. And I just remember you kind of weren't really interested in these papers, and you would laugh every time I'd say, hey, I got a stack of them here. I read a paper by so-and-so. Did you ever read it? And you'd go, nope. And I said, well, here's what they found. Let me read you this, and these are the results. And then you'd go off on some other direction. I thought, what the hell? He's not wanting to read the research, the literature, right? The peer-reviewed science. And then you finally said to me that those people don't understand it. They're not looking at the system like we are looking at the system. And they were developing these huge soil arrays. I think they were spending $30,000, $40,000, $50,000, right, on all these gadgets and solar panels and pumps and cables and T-posts in the ground with this. It was insane. And you were like, the average farmer isn't going to be able to afford this. They're not going to want to screw around with some soil array in their field. We need something that's simple, something that's affordable, and something that's practical. So I just kind of wanted to throw that in there because I remember, and I'm still reading the research, but I understand it now. And I know you'll be the only one who appreciates this, but I'm reading No Till Farmer, the December issue. And in the beginning, there's, kind of some of the latest news or whatever. And I sent you a text picture of it, and it's fun. It cracks me up now knowing how far we are ahead of the curve with this, that when I read this, it blows my mind that somebody actually spent money, probably taxpayer money, to do this, and that they think it is such a highlighted research project that they need to put it in here. And I love this magazine and all, and it says, I'm reading it to you, measure soil health in one step. Measuring the burst of carbon dioxide gas emitted when dried soil samples are re-wetted indicates soil microbial activity. Now, this was published, peer-reviewed, Soil Science Society of America journal, right? So CO2, carbon dioxide flush can be used when measuring N, blah, blah. And I'm now knowing what I know after 2.5 years of intensively working in this, I'm sitting back going, okay, I've come full circle. Thanks, Rick. I get it. Now I know why you said you're wasting your time digging through the academic research to see what other sensor technology and research there is out there.
Well, the fun part is we published a paper in 1996 about that. Like, hey, you can dry and re-wet a soil, get the CO2 released from it. We can tie that to nitrogen mineralization in 96. And now all of a sudden, these guys are like, oh my God, look at this. Like, yeah, okay. Let's, move down the road. So since 96, we've been moving down the road.
Yeah.
Which ultimately led us to here.
Okay. So where is here? I'll let you, since I talk too much as it is, I'll let you sort of describe, don't give them too many details, because there are people out there like Will Brinton who want to steal other people's IP. So what do we have? If you had to explain it to a fifth grader, how would you describe it?
Well, I would describe it as we're going to dig a hole with a little auger, a little 3-inch auger, about 6 inches deep. And then we're going to put this tube in there that doesn't have any moving parts. It's just got holes in the bottom of it that's capped at the bottom. And then we're going to cap it at the top, bring a tube out of it, and let the soil release CO2 into that tube through oxygen exchange, because we put a bunch of oxygen, in the soil with that tube, and then see how they react. And then we can monitor at our leisure how much CO2 those microbes are giving us in that soil with this little monitoring device.
Right. So without giving them too many details, just what you described took us the better part of a year. You being the chief scientist involved, you were relentless as far as number of holes, size of holes, location of holes. And how did we feel comfortable that we got it right?
Consistency. It's the really fun part about that thing is messing around with the holes is like, because we went through a whole year of that. And so the soil was varying. So we had wetter times, drier times, drought times. We had all these different, scenarios that were in the ground. And then, part of it struck me. It's like, well, you can't put the holes near the top, because as soon as the soil dries out, everything shuts down. It's just these little epiphanies along the way. You can't really put them in the middle, because you can dry out 3 inches real easy. And if you got them down there around 5 inches deep, those soils don't generally dry out that deep that quickly. And so we could still get consistent readings with a 5-inch depth.
Right. So for those listening and wondering what's when you take a soil sample, they claim everything's calibrated to that 0 to 6, right? It matters, right? It matters if you're 2 inches or less, or you're 3 or 4 inches down deep.
Yeah, and the old saying that if you want the quickest way to increase your organic matter, take a shallower sample, because the deeper you go, the way the microbial activity falls off.
Yeah.
But we are putting so much. Oxygen is limiting below 3 inches, generally speaking. Mm-hmm. And the microbes have to have oxygen. They take it in like we do and give off CO2, and that's what we're measuring. And so by putting that tube in the ground, which has atmospheric nitrogen in it, now you've got gas exchange down there at a lower depth, and they're not limited anymore, and they're going to show you who they really are. It just works beautifully. It's just, there's a lot more to it than meets the eye,
right,
that we went through. So
essentially one time, you sort of described it to me, and it stuck in my head as, we're taking this chamber, if you will, sticking it in the ground that has 200,000, am I remembering that right? Parts per million of oxygen, something along those lines. And you sort of likened it to looking at something under a microscope, right? We're essentially taking the gas exchange that's going on down there and blowing it up so that we can see it, because it's happening at such a very, very small micro scale. Yeah. So we've taken something that most of us none of us can see, which is why we don't understand it, right? We just walk, put boot tracks in the dirt, and that's what it is. There's nothing going on down there. So, okay. So we've got this system. So it tells us, 1,000 parts per million, 2,000 parts per million, whatever, 6,000, 10,000 parts per million. What does that mean? Does that mean anything to the average person? And I guess beyond that, what data pool or what information did we use since the soil scientists like to talk about calibration and claim that Malik is calibrated to whatever. Well, what did we use to calibrate that tool?
Well, for quite a while. So when you dig the hole, I'd take the sample, the dirt that came out of the hole, and take it to the lab, analyze it, run the Haney test on it, and look at all these things. So I started developing this data set. It's like, all right. And the fascinating thing to me was, so we're also doing soil respiration. We're drying and re-wetting the soil in the lab, right? We're drying, grinding, sifting, and then re-wetting it, under optimum conditions. We get this gigantic burst of CO2, right? Well, the tube is giving you this really small burst, relatively speaking. And so what intrigued me was we're measuring the same thing here, but in two different forms.
Mm-hmm.
You know, a highly disturbed soil that's going into the lab versus one that's not disturbed in the soil, and let it naturally tell us what it is. And they're correlated. I mean, there's a strong relationship between, if you get a super high burst in the lab, it's going to be a pretty high number in the field. But they're wildly different. It's almost apples and oranges. But the fun part about it is that we also got to look at the organic nitrogen from the lab test. And so we got really good correlations between the infield CO2 release and what the lab was saying was our potential organic nitrogen availability. And so that was very exciting, because I think down the road somewhere, we're going to be able to predict or estimate the amount of nitrogen that you have in that soil where the tube is, because we have enough data to support that. And that's really exciting, because you know, if you don't have time to take a soil test or something, you're pressed for time or whatever, you could go out there to your tube, get that number, and we can give you a pretty good estimate of what that nitrogen availability should be.
Right. So going back to that, a lot of my clients listening probably remember me driving all over the country with this tool, or two or three of them in case one broke, which one never did, which was really exciting. It's a very robust tool. And sticking it in the ground, and they're standing there scratching their heads like, what the hell is this thing? And I'm pulling soil out and sending it off to you, and we're comparing numbers. So it was really neat. In fact, I had one, like I said, on an island in Florida. And, you know, we're in all these, you know, you and I both had them in the hill country there in Texas, where it, you know, hit 104 for, it seemed like 13 years in a row. And it was like a week, and I was dying. And when you start to pull all this together, you start to realize, holy cow, we're on to something. This is what we wanted. So I wanted a tool as a consultant, and this is where I know David's falling asleep with his brown water or whatever. He was talking about beer before we got going here, so maybe that's what he's doing, but had something to do with possum, and I don't know. So I can go to a client's property and pull this thing out, and it almost, I'm getting better at it, and I think we'll all get better as we go, but it almost reads like a history book. I can, and I know David's really good at digging a hole. I've done this with him in Illinois, and he can sort of tell you the physical disturbances over the years, looking at plow zones. It's really an eye-opening experience. And I feel like we're using the ST1 to do the same thing. I can tell what type of management they've applied and how much that is antibiotic, just destroying that biological system. And to me, once we start to use that as a tool that way, that meant way more to me than do I have 20 pounds or 30 pounds or 6 pounds of organic nitrogen that I can credit. And obviously, I'm not a huge producer, right? Growing crops. So at that point, the nitrogen credit would be extremely important. And those who have used, I think you'll agree with me, that those who have used the Haney test in the past to basically save on their nitrogen application can use this tool to do the same thing.
Yeah, that's where eventually that thing's going to be headed. And, that because we're always trying to move forward in all this. Mm-hmm. But I think the story that really brings it home is when I went to that farmer that I used to work for and known for 40 some years.
Yeah. This is in Oklahoma, right?
I put a tube in his plow ground. He's conventional wheat, loves to plow. If there's 5 weeds after he plows the whole thing. And, so that's just the way he's been for all this time. So I put a tube in the ground, his plowed ground, and then he had a little, grass deal right next to it, and I put a tube in that. And we came back the next day and read them both. And he's seeing the little graph, the little numbers come up on the one. Then we put it on the one in the grass, and I think his plowed ground was like 1,200 parts per million carbon CO2, mm-hmm. and his grass patch was 6,000. And he sat there and he stared at that, and he looked at me and he said,
Rick,
"What are you telling
Rick, you're breaking up a little bit. His CO2 carbon was you broke up.
His CO2 carbon in the plowed ground was like 1,400 parts per million.
Okay, so 1,400 parts per million in the plowed ground.
Yep. And in his grass right next to it, which would be more like a pasture, it was 6,000.
So it's not disturbed. It's pretty much just left alone. Any livestock or no?
Nope. But we're talking about 10 feet apart. Same field, just 10 feet apart.
Right.
And he looked at me and was so shocked. And he said, "What are you telling me?" I said, "I'm not telling you anything." I said, "What are your microbes telling you? They're the ones talking to you." He said, "Well, they're telling me I'm destroying this dirt over here." I said, "Yes, they are." And it was such a moment, because I wasn't on my high horse saying you screwed this up, or that wasn't it at all. But the realization that hit him was just like a ton of bricks. He was just befuddled at that, and it really made him start to think about his soil in a different way. And to me, that's the crown jewel right there. That he finally understood that his soil is alive and responds to his management.
That's right. And to me, that's the ultimate take home, right? So I've been asking clients, how do you know? Is this working? You hear people now, since it's sort of hitting mainstream, and they're practicing regenerative food plotting, or regenerative agriculture, or whatever they want to call it, soil health. And I say, so how do you know it's working? Other than the most important part, I think, which are just pure observation and listening and seeing. But so what other tests can you conduct to know that this is working?
And see, this is kind of an augmented observational test, right?
Explain.
Well, you observe that, your soil looks better, it infiltrates better. This is all observation, but you can put this thing in the ground and let them tell you. Let the microbes that we rely on so greatly tell you.
Right.
This is what we're seeing.
So again, why does someone need microbes in the soil? Why do they care? What are we doing here? Rick?
Yeah, can you hear me now?
Yeah, there you are.
It's breaking up on me.
Thought, David, you still
there?
Why
do we need microbes? Because without them, the planet dies. Not just humans, everything.
Okay, and I think
the entire planet.
So this is what they did not teach us in school, and this is what when I start talking about this in a field, right, with the ST1 tubes in the ground, we're seeing, like you said, we have a beautiful graph and a countdown clock, and we get this number, and everything looks great on the little handheld computer, and they're impressed with all that. But you almost have to back up and accept that nobody understands why the microbes are important. But everybody wants to, what they've heard is, hey, I heard that you, with your food plot products, they don't require fertilizer. And I'm like, oh boy, hey, no, that's my problem, I guess, if I haven't educated people on what I mean by that. Right. So most people who call and they want to get into regen, they understand soil health. Let's do it. They say, I want to cut synthetics like you do. And I still haven't used synthetics since I started this process, because I changed how I look at the system. Now I understand how the system works, and everything I do is geared towards making the environment and the management better for those microbes. So go ahead and explain why a 1,000 CO2 count on our screen is not nearly as good or as good of news as a 6,000.
Well, yeah, and to be fair, of course, it matters what the soil conditions are. Is there water available? Is it wet? Is it dry? Is it moderate? Is it that? Because we see these strong variations in CO2 depending on the soil conditions. And it was fun. You remember when we talked and I told you that I'd spent several days doing all these calculations to account for moisture and temperature and all that crap, and then finally realized that the microorganisms have already taken all that into account.
Yeah, at one point our kit had all moisture meter, and we had a soil thermometer, and then and then it sort of came back around to, hey, this doesn't matter.
So, 1,000 versus 6,000 is just huge. I mean, so we've seen enough, and I'm sure David has, to realize that once you use this thing for a little while, you start to realize, well, this soil's better than that soil, but they're consistently better. Because I've got soils here on my 3 acres that are really good and some that are really not good, and they're consistently about the same difference.
Yes.
So like I got one that's 6,000 and one that runs about 1,000, and the moisture, and they all have the same moisture.
So in other words, the ones that suck consistently suck, and the ones that crank consistently crank.
Yep.
Yeah.
But the most eye-opening thing that I ever did, and I'm sure David's experienced some of this too, was the fun part about this is as soon as if it had been dry for like 3 weeks or 4 weeks, I'm running the numbers every day, and you go out there and you get the numbers. It's like, say it's 2,000, okay, and then it rains. You don't have to wait 4 weeks. You can go out there right now, and that flush happens right now. That was shocking.
So
it's not.
I think
it's not 4 hours or 10 hours. It's right now.
So a good visual for people is after a rain. You just mentioned the dry period, right? You get a dry period, your grass is looking brown and dead, and then the rain comes and it slowly starts to green up, right?
Yep.
Why is that? What just happened? When you say flush, what do you mean by flush? What just happened?
So that's the organic nitrogen that the microbes are releasing as they ramp up. When that CO2 drives up, guess what? It's breaking down organic nitrogen to inorganic nitrogen, and the plants are taking it up, and everything greens up. There it is.
So the microbes are using that moisture essentially in an environment that is now more conducive to them, right? Because they're aquatic critters essentially in and around water if you have pore space. And they're working for you, correct? Like
right.
A whole manufacturing facility full of employees. Would you rather have one in there trying to build widgets and crank them out every day, or would you rather have 1,000 cranking widgets out?
Right.
Okay.
And so it's a really important thing to see, because we've never had a tool that we can just go out there right now.
Yes.
And see what's the effect.
What's the effect? And next week.
Yeah, or in 2 hours, or in 6 hours, or 12 hours, whatever. It's, I've got tubes out here that I haven't tested in a month. And, I'll go test them and write it down and say, okay, what was it, 2 months ago? What was this,
Yeah.
You can track what's happening.
And I think your point when you said to me, you've said this a dozen times or more, what's going to excite me the most? I said, what? You said when we learn something that we really thought was to be true and it's not, or we're going to learn things with this. You've said that over and over and over again. And I've got stories from here in my fields. Both of you guys, I sent you guys a message one day and I said, hey, what do you think I should do with this? Should I crimp it? And I'm not going to tell my whole story, but it was kind of cool. And you guys were like, well, what's the ST1 think you should do? And I put that in the ground, and I did a half and half treatment or application to it, and studied those readings over the next month, and I learned how to be a better microbe farmer just because of that tool, right? Instead of looking at what's going on above the ground, I studied what happened under the ground because of my management application, and I learned from it. Instead of going to a conference or reading from a journal or a book, I went out in nature and did it. So that's just one. I've got dozens of them, and maybe we should bring David in here before he falls asleep. I know he's busy, and I do appreciate you guys. This was a short notice kind of thing. I've had a bunch of crap going on. I know you guys do too. I finally slowed down on my field season, so I'm going to do more podcasts, and I know everybody wants to hear more. David, you and I already have one in the can that I have to tweak and get ready to go out there. But so the reason I wanted to have David is because they don't really want to hear our stories since it's our baby. We've spent years developing it. By the way, it is patent pending. We're years ahead. We're already so far beyond what we're talking about at this point that we're comfortable selling them, sharing everything for the most part. So I wanted to have David on because we had to pick somebody, like I said, somebody else who understood the system, which is easier said than done. And Rick and I decided on David for a number of reasons. And speaking for myself, I've always respected David, because he understands how the system works. He's been there on the wrong side of the equation, so he knows how painful it is, and he knows how to fix it so that growers, farmers, producers, ranchers can actually make money, which is really cool. I don't know many people like that who actually get it, right? They're published in magazines, 60-inch corn, or they're doing this or that, but they don't understand the intricacies of how the system works, and they can't get a client as a teacher from point A to point B or Z. And then the other thing I like about David, before I hand it over to him, is he's not afraid to tell you like it is. I think Rick will agree with me. If he thinks it's a piece of junk, he'll tell you it's a piece of junk. And that's what we wanted to hear, right? We're prepared for the academicians and the people who think that the Solvita paddles are still relevant, right? We're ready for that. So, David, go.
Yeah.
Go.
So I've been sitting here listening to Rick the whole time, and the only thing I can think of is I like ice cream. Like, Rick is like way up there, smart as heck, and like, he brought it all down so I think everybody could understand this, but wow. The thoughts that go through you guys' minds when you're developing this is pretty amazing. And I remember the first time we talked about this, ST-1, I drew it with my hand there. You didn't see it, but I did it. I was driving and we were talking about it a little bit. And then you called me up and you're like, hey, I'm going to be in Illinois. And I'm like, well, I'm in Indiana. No, actually, I was in Pennsylvania.
Yeah, we swapped.
Yeah, we swapped. And I was like, I'll be home in like 12 hours. And you brought this tool out to me. I'm like, this is it? Like, you serious? I was pretty skeptical about it.
We were at some greasy spoon, and I don't know where we were in Illinois. Where were we?
Jacksonville.
Oh, okay, Jacksonville.
Yep.
Yeah.
Yeah, had some good old biscuits and gravy there and all, but
and the cool part was I was like, listen, take this thing, just be honest, do what you got to do, and you're like, hey, do you have some time? Let's go out in the field.
Yeah, and that was my eye-opening experience with it, because we went to a farmer's field. One side of the road, the one farmer, uses cover crops, grazing. He's got wheat in his rotation, which is like unheard of around here now. And following that up with a warm season cover crop, grazing on that. On the other side of the road, it was conventional tillage, fall anhydrous, corn, soybean, maybe corn, soybean, maybe corn, soybean. I mean, just pretty common, heavy synthetic use.
Not to mention, by the way, his fields were all washed out, and and you could see the anhydrous. I mean, I remember that it was just crusted. The soil was crusted over.
Yep, but it was such an eye-opening opportunity for us to learn that we stuck that tube in an anhydrous track, and then we went across the road, in the cover crop, and stuck one in there, and we pulled the readings, and I'm thinking anhydrous, smokes everything. This is going to be horrible. And I was like, what's going on here? Why is this high? As high as what it is, and we started questioning it a little bit. So I think it was like on the cover crop side, which the soil was a little bit cooler and everything there. This had to be like late March or something like that. Yeah. So it was a little bit cool still. Compared to the work ground, but the cover crop side was maybe 1,400 or 1,600 parts per million, and then the air was like 800. I'm like, man, I thought this would be a lot lower, and they're like, well, duh, this is going to have a lot more bacterially dominated soil. So we put the spade in the ground. They're like, let's look at this. It's just a collapsed system. And the bacteria, they have infinite need for nitrogen there they can consume. And it's like, okay, well, let's put it in between the nitrax, and then it dropped down to like 600, and so it was really cool to see that right there in field and learn from that. And it kind of goes to, as understanding ag, as consultants, we talk about and educating farmers and producers about the principles of soil health, the 6 principles, but the principles drive the 4 ecosystem processes. which are, capturing photosynthesis. So you're feeding those microbes through root exudates, and as we're doing that, we're building aggregates. When we build aggregates, we have better water infiltration. We have better water infiltration, and we have better nutrient cycling. And to get all of this, we need to have a community dynamic of diversity. So diversity of plants, diversity of microbes, And this has been such an eye-opening tool everywhere I go to put this in the soil and to compare different management practices against each other. And to really tell how far somebody is on their journey, really. I mean, I was in Southern Illinois here earlier this month, and we had this on a field that, it had history of turkey litter application on it. And, I think maybe 5 or 6 years worth of cover crops. And then right across the road was some pasture that they, within the last 5 years, I guess, have converted some row crop ground into pasture, and they rotationally graze across it and everything. And on that pasture ground, it hit just 9,800 within 15 seconds. And I was like, man, this is cranking. And we walk over to where they're pretty proud of the nutrient application management that they've been doing over the years. Not saying it was bad, but it was 1,200. And, so it tells us a pretty big piece of that puzzle of management. And then, like I said, you put that spade in the ground and look at, do you have aggregation or do you have a collapsed system? And that starts to tell you, is it more of a fungal or bacterially dominated system? And, we can predict how we're going to infiltrate water or just run water off. And then, how are we going to cycle those nutrients? How much money are we going to have to write out checks to the co-op for? So it's pretty cool.
It's good stuff. Yeah. So I want you to know, and I told you this before, if, we want your honest opinion. You're not really helping us out. We wanted to know, what are we missing here? What's wrong with this tool? Why wouldn't people use it? And Rick, you probably remember me saying to you, yeah, I can see, consultants like, David and those guys. And of course there's a lot of them out there, but Rick, you and I, our first conversation, you were the one who said it. You said, yeah, I want this tool to actually help farmers for once, not some academic who got a big research grant. I want this tool to help a farmer where they can go in the field. They can not only learn how the system works, but they can save money and make money farming again. And I want you to talk real quick about something that I thought was kind of cool because it helped me understand the biological system better. When we think about biological systems, we walk around, we see people, we know if we throw acid on them or something on them that they're going to die, it's going to be nasty, they're going to get sick, whatever. But you said to me one time that we're not measuring CO2 burst, or I think you said we're not measuring life in the soil. We've been measuring their survival response to it. Do you remember that?
Yeah.
And I can kind of fill in the dots. It sounds like you get it. But you said to me, we could take a piece of dirt, we can dry it, we can re-wet it. That's after shipping it across the country or whatever, letting it sit out, in the garage for a couple weeks. We can re-wet it, and it comes to expletive life. See how I did that? It comes to expletive life. And I was like, that's crazy to me, right? It didn't make sense to me. And I've had clients say this, can you just cover this elementary topic of if we can't put our kids in a FedEx box and ship them out to Texas and still have them in good condition, why can we take a soil, if you tell me it's biologically active, and ship it to Texas and the stuff's alive? Can you explain that?
Well, yeah, that's the amazing thing about soil that we don't seem to comprehend sometimes is that it's incredibly resilient. Just like David was talking about the anhydrous tracks versus the in between the two. It's like there's still microbes there. Even though you injected a gas in the ground that comes in at pH 13. And it sucks the water out of the system. What do you think the osmotic shock is to a microorganism when that gas sucks all the water out of that cell? I mean, it's just incredible. but they have survival mechanisms, and they wouldn't still be here if they didn't. So it's absolutely amazing to me how resilient soil is, and how much it has to teach us if we can just get in there with the right devices to listen to what it's trying to tell us and move the needle on our understanding. Because this whole thing is designed to educate us, not the microbes. They know what they're doing. They're not political supporters. They don't have egos. It's a predator prey world, and they have to survive. They have an enormous amount of survival mechanisms. However, if we treat the soil poorly, the problem is they're niche players. So you're going to select for certain microorganisms or certain functional groups depending on your management. And what we miss is that's really important. It's really important. It's the whole ball game. If we manage soil correctly, they will respond right now. It might be 6 months to a year to 2 years down the road before you see that economic return in the way that you believe in it. But you've got to start the process now. You can't wait. Or what was that? Don't be a wiener. Remember that? You don't want to wean off of,
Yeah. Yeah. Don't wean off. Yeah. Just go all in. That's like, yeah, you and I had that conversation dozens of times because I have to actually, and David even to a greater extent, because these people are making money off of it, and my clients and friends, et cetera, are managing properties. They're into the ecological value, the restoration, and ultimately killing big animals. But yeah, we had this weaning people out there talking about weaning, and I'm not speaking for David or anybody else, but the wildlife, people who own tracts of land, and they want to restore it, they want to regenerate it, they want to do what's right, and they want the ecosystem to function naturally so that they can enjoy that and pass that on to their family, etc. And Rick's response to me was, "Don't be a wiener." And I said, "All right, that's kind of what my gut tells me, is that this weaning off of whether it's chemicals or synthetics or neonics or whatever, stop being a wiener and just go all in."
See, that could be the T-shirt.
Yeah, that's the next
-1.
There it is.
Don't be a wiener.
Go all in. So I think that, to me, that the question became, okay, so who is actually, who are you experiencing any gains, right? Are we getting anywhere with this? Because we're doing all this new stuff, and as David could probably give us story after story after story, it's shocking when guys say to me, "Wow, you haven't used fertilizer, synthetics, or chemicals in 6 years, and you guys are still seeing just as many mature bucks and actually more turkey poults, etc." And we are right here. It is. We're doing it. I want to go to that, and then they stop cold turkey, and it's all of a sudden like dealing with some wimpy little geek. They're like, some big man, and they're like, "Oh man, this is looking rough, and my neighbors are going to kill all the deer, and it's just painful." And I'm like, "Well, listen, suck it up, stop being a wiener, and in 2 or 3 years, you're going to notice that everything just explodes." Or you could drag it out and wean off and wait for years and years and years. By the way, let's look at what this tool has to say. Most of us, I think, have been trained to look above ground, right? There's nothing going on below ground. And David, as far as I'm concerned, is the best at this constantly. I'll send him a text or call him often, and I'll say, "Man, this is killing me. I'm racking my brain over this." He's like, "Well, when you sunk the spade in the ground, what did it show?" And I'm like, "I didn't even have a spade." And he's like, "Well, what the?"
Yeah. What's wrong with you?
Yeah, you don't know what's going on. And so I guess I'm just rambling, but David, do you have anything else that, and again, are there any, I can't wait. I can't wait for the academics to but us to death. Yeah, but, because this system is so simple. Again, checkbox. That was one of our initial goals, right, Rick? To actually help farmers, to make it simple and affordable. Check.
Yep. Well, I'd like David to tell the story about when we were up there on that CRP ground up there in northern Kansas.
How come I wasn't there? I like Kansas.
Yeah.
Remember that, David?
Yeah, I do. I was going to allude into that because
do it.
One of the things that I wanted to talk about too was like, I wanted to play devil's advocate, with you guys on, how the academic world is going to view this. Because the original ones, you had the sensor in this cap, and we had to take the cap off, put this one back on, fumble around with it. You're putting in a dip with one hand, taking a leak with the other.
Yeah.
You might have to edit that, but
drinking bourbon with the other.
Yeah. And I was like, how much are we losing? And Rick's like, well, not really. But he got to the point, he's like, okay, fine. Please, I'm going to put this little pump deal on here and just go draw it across. And so it was really cool once we had this pump, even before that. But, we were in the CRP of these warm season species that was over my head. I'm 6'2", and it was gorgeous. It just needed some livestock or something in there, bison or whatever you want to throw. But we dug into that soil, and it was just rich, crumbly, just amazing, beautiful soils. And without even sticking a tube in the ground, we could just take that pump and just run it around the inside of that and just watch the spikes occur. We could see that activity was occurring there, and even above that hole, above the canopy, and then through that canopy, you can tell the difference of the capture of that CO2 through photosynthesis of those plants. And I think that's probably one of the biggest ahas right there of proving that we are actually capturing CO2 in our soils through living plants here, cover crops. When I talk to all these row crop guys that are just tilling the heck out of the ground, don't have anything growing for 7-8 months out of the year, is they're giving up so much opportunity to feed life and keep things going. And when I'm sitting there with this pump, and I can take it right at underneath the corn stalk residue and see what the CO2 is there, and put it right above the corn stalk residue, see what my burst is, what's happening there, and then take it right up to that leaf surface area and see what's happening, and then go above that plant, that green living plant, and see where it is. And heck, it's less above that plant than it is underneath. I mean, it's amazing what I'm learning with this. But yeah, up there, when me and Rick were up in Kansas looking at that soils and seeing, how quick that burst happened. It was within 5 seconds, wasn't it, Rick? It was just...
Yeah, it was shocking. And it was so far out of Gabe Brown's league. It's just he didn't even want to hear it.
Yeah.
He's like, well, we ought to test fine. It's like, you won't ever get there, dude. You'll never get there. He's like, oh, well, we'll see about that. It's okay, whatever. He was funny because he goes, well, I guess got something to shoot for now. It's like, yeah, I guess so.
Yeah.
It's like David saying, what is this thing going to teach us? There's stuff that we're going to be able to do with this that we haven't even thought of yet. And just like David's talking, we dug a hole up there in that. And so I was having trouble with my configuration of my tubes and pumps and all that crap. And so we got it working, and we just took the tube and stuck it and put it in the hole with no tube in it or nothing, no big tube, and just moved it around the bottom of that hole. And you were getting all this CO2 coming out of these sides of the dirt and, from that hole. And it was mind blowing.
Yeah. I remember when you told me you did that, and I didn't tell you this, but I went to a client's. I took everything with me in the pickup. I love driving if I can for this reason. And I got there, and I was almost there thinking, if I can get there the evening before, I can sink a tube in the ground or 3 or whatever and let it do its thing overnight and check it tomorrow. And I was thinking about it, and I was like, oh, no. I left all those tubes sitting on that chest freezer in my garage. I didn't bring a damn tube. So I was like, well, let's adapt and improvise. And I did that, but I never told you I did that, Rick. Yeah, and it was it wasn't obviously it wasn't calibrated to what we're doing, but it was the same take-home message. Everything was still applicable. It was pretty neat. That to me, that was the day I realized, wow, when they call these things a robust sensor, they're no joke. I mean, they're super sensitive.
Well, the other fun part is just a quick backstory is that, 2 years ago we were developing this, and I at first had the passive system that David was talking about, and I was taking my laptop with me to Oklahoma. And you were like, oh no, nobody wants to carry a laptop. I said, I'll screw that. If you're such a wimp, you can't carry a laptop, up yours. And so but then I go out
That's
there. That's
exactly what you said too.
And after 2 days, I went, screw this shit. This is a pain in the ass having a laptop out here.
Yeah. Yeah. Mine's got sand in it. It's practically destroyed at that point.
So then, we get the system going, and then David, oh, well, what about how much you lose when the cap comes off? And it's like, whatever, dude. It's not a big deal. I've tested that.
I
thought,
where,
okay, fine. Because I said you're going to use a laptop, go to the field. We're not using a bunch of pumps and tubes and crap.
Yeah.
And now we did away with the laptop, and we're using pumps and tubes and crap. And,
but very simple. It's a very simple version of that. But again, this is the disconnect, and being able to work so closely with you for 2.5 whatever years. This is the disconnect between academics. David, I know you mentioned that, playing the devil's advocate, and for the record, Rick just retired. Well, not just, but retired back in the spring. So
August.
Was it August?
August 30th.
Maybe you were mentally retired back in the spring. Sorry.
I've been mentally retarded for a long time.
But you used to say to me, we stop worrying about what the academics are doing. And I was worried about what the academics were doing. I was looking for the holes in the system, in the tool. And I kept saying to you, well, you know what? Sometimes I pull up to a tube and, I might be looking at a text with my one hand or I'm trying to pop it off and I fumble it. And you're like, no, don't worry about that garbage. The microbes, this all works out. Let me show you. And the regression line, everything looked good and all the data looked good. And then David brought that up and you were like, all right, you guys want this fixed? I remember saying to you, you said, we're going to fix this. I said, no, if you insist, you think it's fine, there's no reason to fix it. And you said, it is fine, but the reason we're fixing it is because I want to eliminate one more thing that you academics can be concerned about.
Yeah, that's right. But in honesty, that was the right move. It worked better. It's faster. It's more precise. It's just better. I mean, I messed around with the 2 ports in the top with it closed, and so we're just gonna go in and out and recycle the whole thing. It's like, no, that's not how nature does it. So we're there now. I'm pretty happy with where it is now.
Yeah, and for the record, when I started, I would get CO2 readings to 2,600, 3,000, sometimes over. If we just got a major rain and a flush, whatever, I'd get more, obviously, but it fluctuated in that range. And then I started to say, all right, I'm going to listen to this thing like Rick says. I'm not going to worry about what the journals say and what all the people on fake book, which I'm not on anymore anyway, and I don't need it. And I would start to follow this thing and say, all right, this is how this works. What does it want? And then I would do it, and I would do a treatment, a control, and I would say, okay, that's what it wanted. I get it. And towards the end of the summer this year, I was maxing the sensor I was using capped out at 10,000 parts per million. And I would put that thing on there, and in anywhere from 3 to 7 seconds, it would just spike and hit the ceiling and tabletop at 10,000 parts per million. Now, that obviously it's not Gabe Brown's soil. Nobody's his. But
his would be like probably 4,000.
My point is people think they need soil tests, and don't get me wrong, using the Haney test was instrumental. It was key. We would have never gotten anywhere without, like you said, taking the actual soils, sending them to the lab, and saying, okay, what are we really looking at here in the field, and is it worth anything? And I think this unmolested, in situ, in the field, doing its thing with nothing but the management and nature, and listening to that system respond it's mind blowing.
It really is. And but to be fair, I mean, the soil testing is still a big key part of it because soil is not just about nitrogen and carbon. I mean, there's other things, but used as a tool to augment your understanding, this thing is just really going to be something, I think.
Good deal. Is that where we stop, David, or do you have more?
Oh,
I got all day.
Think
you said you were going to play devil's advocate. Do you want to play devil's advocate?
No, I mean, I was going to just mention, just like you said, with rolling down cover crops and doing different things like that. Not even go to the conventional versus cover crops or whatever type of management, or high synthetic versus low synthetic, but that rolling down a cover crop with that too, with this, the ST-1, just is like mind blowing what you can see and learn from that. It's telling us that, again, get the soil covered. That is huge. And
Yep.
I think a lot of times throughout all these conferences and everything else that people go to and listen to, that they think, well, I got a cover crop out there. It was covered ground. I terminated it at 6 inches or 12 inches, whatever, but by midsummer, their soils are bare, So you're taking on all that heat and everything, all that environmental impacts to that soil. Same thing if that cover crop is standing, it never really melts down to completely cover that, that house basically. So rolling down that cover crop, getting the roof and the insulation in the attic of that house is absolutely critical to really start seeing an improvement in soil health. And this tool is just the ST-1 is showing me exactly what I've been wanting to see. You can do an infiltration ring, which I'm not a fan of, dig in the soil or whatever, but this thing can tell you exactly what's happening.
Well, and think about how fun that is, because so it's like you got this cover crop, and this guy, and you crimp it, and you do that, right? And let's say you got a tube in that one, and then over here you didn't crimp nothing, so you don't really have that armor, right? I will guarantee you that there's going to be, and you well know, more moisture where you crimped it because you got that cover, right? More moisture means more microbial activity, and that tube will show you the difference right now.
Exactly.
Not 2 years from now, right now.
Yeah.
And that to me is, and think about this. So let's say you were wondering about this fungicide or that nicotinoid or whatever. You could drill a hole, spray a tiny amount of that in there, put the tube in the ground, and then go 3 feet away and not spray anything in there, put the tube in the ground and look at the difference.
I wish we would have done that.
I mean, it's just I have done that.
I know.
Some of these so-called biological things, and the fun part is they didn't do anything.
No. Well, some of them took an immediate spike and then they crashed.
Some of them actually went down with the treated stuff, and it's like, so again, and I did this my entire career. It's like, let me ask nature what is happening here, because it's got, the soil contains an enormous amount of history and understanding that we're just now beginning to tap into. And so, we try to rely on our whole 100 years of academic research to guide us forward, right? Well, that nature's got, millions of years of quote unquote academic research under its belt. And so why are we not asking it?
And the unfortunate thing is, in the last 100 years, we've done a really good job at destroying everything instead of actually understanding how it was designed to function.
Yeah, but maybe that's why you young guys are. Maybe it's your time to turn that corner.
Yeah, we're working on it.
Yeah.
Well, I think one thing that we talked about one time, Rick, that I always tell people is this puts us in the field, which is originally what I wanted. Right when we were talking about it, that first conversation is we want to be in the field, and again, I'm not a big fan of
we made a conscious decision not to try. Now, not that you couldn't, but to not integrate everything where you can sit in your office and monitor 45 tubes.
Right.
All right. We want the consultants, the farmers, the whoever's to go out in that field, check this tube, because you're going to see something you probably haven't seen before. You're going to observe something about your land, about your ground, about your plants.
Yeah, especially if you're with someone else like David or you or because the more people, the more observations are made. And I'm kind of chuckling because you're right. That's one of the initially we had some people say, well, can you get that in an app and put it on an iPhone or an Android? And can you put that in a network so I can sit in my office at the farm and just watch all my tubes at the same time and see how they react? And we were like, yeah, sure. It's pretty easy. All it takes is a little bit of money. That's just sitting around getting moldy anyway. But here's the thing. We don't want to do that just yet because we want you to get up, get your ass out in the field with the tool and the spade and learn. That's where you're going to learn, not sitting in some office somewhere looking at a monitor.
Well, when I was at USDA, my boss, back years ago, kept asking me, why are you out there driving tractors? Why are you out there running combines? You got a technician for that. We can get people for that. You need to be in your office, writing papers, blah, blah, blah. And I said, because I need to be out there, because I need to see and I need to think and I need to look. And he's like, well, whatever. And he comes back a day later and he goes, okay, I understand what you mean now. I said, okay, then. And that was the end of that conversation. He never said anything about it again because, some part of him was like, oh, yeah. I mean, that's where you think. That's where your brain's kicked in. If you're sitting there at a computer and you're monitoring all these sensors and stuff, it's like, okay, that's fine. There's some distraction. You're over here doing all that.
Yeah.
If you got to walk out there, you're focused on what you're doing. You're thinking about what you're looking at. That's just a whole different game.
This, we're fine on time, but I personally think this is a great conversation and a great topic that honestly you're not going to hear anywhere else because nobody else is doing this at this level. But I have like 3 or 4 things wrote down. That the one thing that I wanted to bring up, Rick, and maybe this is a moot point. Maybe you don't believe in it anymore, but I remember the cat woke you up one night. You remember that?
Yep.
And you said, well, I can't get back to bed. And this is when we were in the thick of sticking tubes all over the country in different management, in the woods, in fence lines, in potting soil. And you decided to go out, I don't know, it's like some crazy 1, 2 in the morning, whatever, and test. And you said to me, did you know microbes are nocturnal?
Yeah.
And this is the next morning, and I was kind of half listening to you, and I was like, you mean like bucks being nocturnal or crepuscular? And you're like, yeah, they're nocturnal. I said, go ahead, I'm all ears, explain. Do you still believe that explanation and that observation?
Yep. I mean, you think about it. The sun shines, most all the time. The plants make photosynthate, dump it out the roots. When the sun goes down, they probably dump some excess carbon they don't need at the bottom of the roots or whatever, and the microbes come alive because they don't need sunlight to make things, to do their thing. They live in the dark, right? So I was seeing this over and over. So I put a data logger in the ground, and here it was over and over for 3 months. And I've done this several times, and it's just clear as a bell. The sun comes up, the CO2 drops off. And then when the sun goes down, the nighttime shows up, here comes the CO2. And right before daybreak, bam, it falls back down. And then here it's just cycle. It's like
almost
a sine
like
wave.
It was designed that way, right? That's crazy.
It does seem weird like that, yeah.
I remember when Jason was telling me about that, and I was like, I had an aha moment, 2x4 across the face. I was like, duh, that makes all the sense in the world now, because a few years prior, I had a trail camera set out on corn, and I was watching it, every 2 hours. It was taking pictures, and I did a time-lapse video of it. And like between 1 o'clock in the morning and 5 o'clock in the morning, it would look like that corn plant was like there was a windstorm coming through or something. It kind of start twisting, get kind of gnarly, and shoot up a little bit. Farmers always talk about, man, it looks like that corn grew overnight. Well,
yeah, it
did.
Yeah.
And it's all because of those microbes exchanging nutrients to it and everything. I'm like, duh, this makes all the sense in the world.
Yeah. Well, I remember when I was a kid in Iowa, grew up in Iowa, and we were on those detasseling crews. We had detasseling, and I swear to God, during the summertime, you're out there detasseling, it's dead quiet, and you can hear that corn growing. I swear you can hear it. You're stretching and cracking and popping. It's like, good God. You talk about putting up and picking down some ATP. That's there it is.
That's right.
That's a good use of a trail cam, David. Super proud of you there.
That's right. It wasn't the fancy one that, sent it to my phone or anything like that. But hey.
No, that was a story that I wanted you to tell. I thought that was really cool. So microbes are like me in that they live in the dark, and they're like David in that they party all night.
Yes.
That's really cool.
So they're a hybrid of you guys.
Yeah.
It turns out.
Yeah. Although lately you've been the party all night guy.
Oh my God. These kids, these 30-somethings from Austin are killing me. It's like I'm twice your age. Come on.
All right. I've got another one that I don't know if you could tell this or not. Do you remember the story as you were about to retire and you were walking around your office in the grounds and you were weeping because you had to leave? And you found some old dusty soils.
Yeah.
Can you tell that story?
Yeah. So we had
before you start it, that story, I remember when you told me, I was sitting on my deck, and I remember where I was sitting because I was like, I wish I would have known this 7-8 years ago, because it was an illustration of how resilient biology is in the soil. And I think if some of my clients and some of the listeners can hear this, it might encourage them to say, because sometimes they hear guys like me, you and David say, well, look at, you've destroyed the soil. Look at it. There's no infiltration. There's no aggregates. There's no life. It's not covered. It's blah, blah, blah. And they go, you know what? Screw it. I quit. It sounds like it's, I've destroyed it. I'm not going to, the soil scientists say you can't improve it in a lifetime. So to hell with it. And then you told me this story and I was like, see, everybody needs to hear that story to gain an understanding in how freaking resilient soil biology is. Go.
Yeah. Well, so we had the research station in Temple, Texas, and then about 60 miles away was another smaller station that was basically grazing lands and stuff that was part of the station. So it was, a bunch of pastures and stuff. Anyway, they had a bunch of plots out there that had been sampled. That place has been there forever. And so technicians were up there one day and they had brought back this boxes and boxes and boxes of dirt. And I went over and I said, hey, what do you guys, what is that? And they said, we found these in a basement of one of the buildings up there. And written on those, they were little ice cream containers with soil on them.
There you go, David.
Had
There's your ice
fields
cream.
Marked. Yeah. Had the fields marked, and the date was like 1946. So they had been sitting in there for 60-some years, or back then. And I was like, oh my God, we're going to take these and run every one of them through and do the Haney test on all of them. And we did. And it was so shocking because these had been dried and ground and sieved and put in these little containers. And the fun part is we had just pulled samples from the very same fields like a week earlier and run them. So now we've got those same soils from 60-some years ago that we're running now. So how do you get that opportunity? That was just, I was so excited like a kid. And it's like, and we ran those, 30% of those came back huge. CO2, like 400 or 500 part per million CO2 bursts, just unbelievable. But what stunned me was the water extractable organic carbon in those 60-some-year-old soils was like over 2,000. And the ones we had just run were 500. And it's like, my God, what have we done? And, and now the 70% that barely gave off any CO2, we just left in the incubator and tested them the next day. And sure enough, about half of them came back. Some of them never came back.
Okay, so 30% came back to life.
About 80% of them, or 70% of them, came back after 2 days.
2 days, all right. But you had some that came back almost immediately, or was it a day?
And I don't know why.
So just to be clear, Rick, the 30, didn't you say you had 30% come back to life almost immediately?
Yeah, the first day.
Okay.
It's the 1 day CO2 thing. They were there. It's like I was shocked. I didn't think there'd be anything. And it's like, how can this be possible? Set on a shelf in a basement for 60 years. And that's what it taught us, you and me both. It's like, look, the soil is resilient. All we got to do is give it a chance. It's like we're standing there. It's like, somebody laying on the ground, you got your foot on their throat. Take your foot off their throat and it might breathe better.
Yeah.
Might come back to life. There's no excuse for saying, oh no, screw it. You can't fix it. Yeah, you can. And you can fix it fast. It didn't take 100 years to grow soil. It takes about, 2 or 3.
Yeah.
If you're intentional.
Yes. If you're intentional. That's correct. That's just a story for the ages, right?
Yeah, I thought
what a shocker.
That's an awesome story. That's why I saved it to the end, because I think anybody.
So I told this professor at Baylor about it, and he was like, "Wow, that's so cool!" And a week later, he sends me this soil he's a geologist, that they dug up somewhere that was 15 million years old. So I ran that, and it was absolutely dead. That was funny.
What kind of ice cream was it?
I don't know, but to be devil's advocate, I ground up some of those ice cream containers and extracted them to see if carbon had leaked out of the ice cream container into that soil, because I couldn't believe how much carbon was there. And we saw no effect from those ice cream containers at all. So that was real. And boy, was that something.
That's good stuff.
That's amazing.
All right.
Before you wrap this up, Jason,
yeah,
I really, really appreciate the whole not having this on a cell phone app and getting farmers out into the field. And I can't remember, I was thinking of this when you guys were talking, if it was Wendellberry or who said it, but it said that, farmers cannot be good stewards of the land if they're not on the land. And you think about some of these farmers that are farming 70,000 plus acres, or even 5,000 acres, they don't have that intimate connection to the land anymore. And they just put a hired man in a tractor to drive, and maybe now an autonomous tractor and an electric tractor or whatever. So they're not even sitting there and understanding what the soil's doing. Why is it eroding? Why is this happening? Nobody asks the questions why anymore. And so that's really important that, this stays where, the farmer has to go out there, the practitioner has to go out there and actually physically be on the soil.
Yeah, I think that's crucial.
Yeah, and we've fought this, Rick. People who I'll call them investors, or just people who are interested, calling and talking to us, that this is immediately, how about it, where they go. They want huge networks and apps, etc. And I'm sure this will go there eventually.
Oh, it will.
And we can do that now if we want to. But it's like somebody else, some others who have known what we're doing keep telling Rick and I, you need to hurry up. You guys are dragging your ass. This is incredible technology. One local no-tiller said to me, 3rd generation, he said he saw it in his field. And this was kind of one of my aha moments, because I kept saying to Rick, farmers aren't going to want this. Farmers aren't into this. I mean, they've got yield monitors and they're pretty John Deere, and that's all they care about is yield, yield, yield. And he looked at me and he said verbatim, do you realize what you've got here? And, so we've kind of just been taking our time with what, we don't know. What do we have? Because we keep learning stuff. It's been 2.5 years or whatever, and we just keep learning from it. And I think, that this to me, soil testing is important. I get it. Lab soil test. Lance Gunderson. I did a podcast with Lance. I know you guys know Lance, and he's, as far as I'm concerned, he's the only lab. And anybody can. He doesn't pay me to say this. He's not a sponsor. He is the only lab, in my opinion, in the country that's currently worth a shit when it comes to PLFA and the Haney test and all the other stuff he does. But as important as in-lab soil testing is, if you want to know what's going on in your soil from a microbial standpoint, right? Which when we talk soil health, there's only one. Correct me if I'm wrong. Somebody educate me, but there's only one parameter we can look at when it comes to life. the microbes, and that's the CO2, right? That proves that they are breathing in and breathing out. Now, there's other.
It is. And I had it because we had a call. I actually am working for Lance, and so we've been on some calls with these companies that are a bunch of modelers. And this one guy was like, "Well, we have a biological component in our model." And I said, "Well, what is it?" He said, "Organic matter." And I said, "Oh my God, you don't even understand. That is not biological. That ain't even close." And he got off the phone. He didn't want to hear that. But that's where we're at, and that's what we're doing. And we're going to try to change that metric at some point.
Mm-hmm. Well, I think this tool gives you the answer. It's the next step to understanding, in my opinion, soil microbial activity. And I don't know. I think it's the answer to being able to become the art. As I tell my clients, you want to get good at the art of farming. You want to use this as a tool. Maybe that 2,000 or 8,000 CO2 doesn't mean anything to you on the surface, but knowing the history, knowing what you're about to do, and David brought up the soil health principles. I mean, this tool has, and I don't know, I don't really care who developed 1 through 5, and then they added 6, but this tool actually verifies that, that's right. Cover the soil, maintain living roots. Obviously, the more complex we get on rotations, all of these things fall right into line. When you have this in the field, it's like, holy cow, this is all, animal integration. How about it, Rick, on that one ranch where the pigs were early on?
Oh, my God. Yeah. Wow. That was amazing.
It just blew up. It spiked, and I don't even think you had a tube in the ground.
No,
or maybe you did.
Oh, no. Yeah, I did. As a matter of fact, I had a hard time finding it, but I found it. And yeah, it was really interesting. But, David, you and Shane had mentioned when we were up there in Kansas that, boy, if you had some of those water sensors buried in there and a tube with them, boy, that would be interesting, wouldn't it?
Oh, yeah.
There's just so many uses here. There's so many things we haven't thought of yet. But
yeah, obviously the future and what this can be integrated into is sort of mind-boggling as well. And all that's cool, but to me, the start is more important than all of it. And I hope that can happen with the technology and actually help people learn more things. But to me, the simplicity and the fact that a farmer can take this and of course everybody's thinking, how much, where do I get it? Well, we'll talk about that here when we're.
Oh, I figured that out. It's 350,000 pesos.
Is that what it is?
Yeah.
All right. We'll leave it at that.
And also one of the last thing is, so we really, really wanted it to be simple so that anybody could use it. And that's why we chose David.
That's right.
I'm just going to let that lay out there for a minute. I didn't know if he wanted to respond. He's smart enough to not respond. He's just going to.
Yeah.
Whatever.
Yeah.
Whatever.
I mean, he's a doctor, and I'm just.
Yeah, whatever.
Yeah.
The guy.
Yeah, he's one of them.
You say that, if you got to show him your PhD, that, you still have to pay for your coffee.
So we're talking about the future. Let's talk about the past. In my opinion, this just left the Solvita paddles in the past because there's been a couple of people who I've introduced this to, and they said, "Oh, that's basically like the Solvita paddle that you throw into a little mason jar with some dirt and go back 3 days later and it says X, and go back 6 days later and it says Y, and go back 9 days later." And there's a delay there. I might be exaggerating, but for anybody who wants to argue about the Solvita
example. This guy in South Africa is a researcher, and I'd sent him one of my little mini cubes for lab analysis for CO2.
Yeah.
He said, "What do you think about Solvita?" And I said, "You mean the thing I came up with?"
Yeah.
And he's like, "Well, that's a whole other story." But anyway,
that thievery of intellectual property that Will Brenton and Keith Burns and others are really, really good at. Go ahead.
Well, but he said, "What about the Solvita paddle?" I said, "Well, yeah, you can use that. I mean, it's pretty cool." I stopped and I said, "Well, ask you a question." He said, "What?" And I said, "Why would you measure something that you want to see, like CO2? Why would you measure that indirectly when you could measure it directly?" And he paused and he said, "Well, that'd be stupid." I said, "Yes."
So can you just briefly, because I know the history of the Solvita paddle and what it was originally used for, compost, and then you came up with an idea that then Will Brenton stole and continued to profit from, which whatever. He adapted it ever so slightly, but you don't have to comment on it because I know how you are. You're humble. But screw him. I know what he did. It's coming from Snavely. I'll give him my email address at the end. I've been wanting to talk to him. I heard he sold his lab. Good for him.
With some cool technology, but he was using that for compost. And I approached him and said, hey, I have a method that we can use this for soil in just 24 hours. And he reformulated the paddle, and that's how Solvita was born. I did all the calibration work and all that stuff. And, it's just, yeah.
But it's not, again, going back to how it compares to the ST1. So you trap CO2 on the surface, right? You put it in this, you put soil in the quart jar or whatever, and there's no gas exchange. It's not a natural system. Your soils in your fields are not encased by a mason jar.
Right. No, this is a much more direct measurement. It's a much more direct measurement.
Yeah.
And I like direct. I think it's more accurate and all that stuff. So yeah,
you're too humble.
Yeah. Use this.
You're too humble.
Cool.
All right, I'm not in a hurry, David. Anything else? If they want to stop listening, they can. I mean, I literally, Rick. Just so you know, I know David. You mentioned initially about listening to Rick talk. I have a notebook journal thing that I'm a note taker. Those who know me, I take a lot of notes. I've got a book written in here on notes. Just to me, it helps me think later, and I come up with different ideas, different questions. I could talk about this topic forever. In fact, I'm so excited. My email is jason@droptinewildlife.com. If you want to use jason@droptineseed.com, that's fine. I love it when people, and there really hasn't been a lot of negative input from it. But again, we haven't really been in a hurry to get it out, right? Here we are. It's not the growing season. I think the growing season of 2022 is going to be the big introductory season for the ST1. And of course, Rick and I have some other technology right behind it that's ready to go as far as looking at soil aggregates and infiltration. I know, Rick, it's not technically infiltration, but why wouldn't you want to listen to the microbes when you're testing for aggregation and infiltration, like David mentioned, using the ring, which is cute, but it doesn't really excite me as much as actually listening to the life.
The microbes are way better at telling you what the aggregate stability is in your soil, in the soil. They're very good at it because they live there.
That's right.
Yeah.
What did we miss? David?
I can't think of anything right now.
Rick?
No, that probably said plenty.
Yeah, I've got a bunch of nerdy stuff that I could talk about, but I think we hit the bulk of it. And there's that. There's the introduction. There's a lot of details missing, and a lot of good tequila and bourbon that we didn't talk about that are no longer with us. And I think we'll talk about more of this in the future as we continue to learn more and use it in other applications. So again, if anybody's interested, or you have a question or a comment or whatever, Will Brenton has a comment, Keith Burns, my email address is jason@droptinewildlife.com. And thank you two. I know you guys were busy today. I kind of just dropped this on you. I wanted to talk about it.
That's just how good David and I are, though. You dropped it on us, and we just made it happen, and then we'll go on and dominate the world. Right,
that's
David?
right.
That's right. It's like dealing with Pinky in the brain.
Well, we've been wanting to do this for a long time, so I appreciate you guys. And with that, I hope everybody enjoyed it, and stay tuned. Like I said, David and I have got a really good episode that I have yet to put out as well on neonics. So stay tuned. Thanks for listening. See ya.